Now, if I was going to perform operations with differentials, I would need to know how they behave. And fortunately enough, there is only one rule we've got to work at, and it's actually a pretty intuitive one. So it has to do with calculating the differential of the product of two different variables, or here I've written this two different quantities. I've chosen the letters U and V, but this can work with any pair of variables. And the formula is if you're calculating the differential of a product, then you get the first variable U times the differential of the V variable plus the variable V times the differential of the U variable. And I claim that that is actually a very intuitive rule so long as you have the right picture. And here is the picture that I want to look at. I have in purple a rectangle with side lengths U and V. So I know from regular geometry that the area is going to be U times V. My question is, what would it mean to take the smallest piece of area of this picture? So I can imagine the U getting a tiny bit larger. And let me draw that in here. My U will be getting just larger enough here. And so the width of this line is representing my differential du. How long is that line segment? It's V units long. I hope that makes sense. Now, this line is already too thick to be a differential, right? I can just count the number of pixels, and that gives me a real number as the value of this area, actually. That line is going to have area from the way that I'm forced to draw it on the computer screen here. So again, here's another example that the differentials don't actually exist. They're just an idea that lives in my head. Now, I can do the same thing for V, and I should. I'm imagining this purple area growing in both the X and the Y directions. So my differential for V is just going to be called dV. That's going to be the width of this horizontal line segment, if I could draw that line segment infinitely thin, which I can't. And the length is going to be this U right here. That's how much bigger the rectangle gets as I change both U and V. Now, there's one last consideration, that I'm missing my corner here. So I should actually have, a bit bigger, yeah. I should actually have this corner piece right here. What would this be representing? Why can't I make that? Here we are. What would this corner be representing here? Well, it can only be du wide, and it can only be dv tall. So this here must be du times dv. But I'm going to say that is so incredibly small, I'm going to treat it as 0. We get to play a little fast and loose when it comes to these things. This is the reason why the differential of u times v is going to be, well, my upper line segment, my horizontal line, has an area of u dv, and I need to add to that my vertical line segment, which is v du. And again, I'm just going to throw away that one little dot up in the corner. That's allowed. So that is the origin of the formula.